and then start the slideshow. There we go. Okay, as Jackie mentioned, I was the lab director at the Lindsay Young Beneficial Insects Lab at the University of Tennessee, where we mass rear predators of the Hemlock woolly adelgid. I started the job in late 2006 and recently retired on December 31st. And I felt I was very fortunate to have that position. Hopefully did a lot of good for the people of Tennessee and our forests. And I also got to visit a lot of the beautiful areas in Eastern Tennessee in doing my job. Rusty touched on a lot of the background of HWA and the problems it has caused. I'm going to mention a little bit more and reiterate some of that because it's important to understand it when I'm talking about how we rear the beetles in the lab. As you probably know, many years ago, it was determined through mitochondrial analysis of mitochondrial DNA of adelgids collected throughout its range that it was found that the HWA in the eastern U.S. Originated in southern Japan, probably brought over here on ornamentals, and first found in Virginia near Roanoke in the early 1950s. So it was definitely here before then. In the other areas where it occurs, it is really not much of a pest. It rarely kills trees. That's primarily because there's a complement of these biocontrol agents keeping it in check. Rusty actually showed this very diagram. I don't really need to go through it. Where we are right now is, of course, the cystins are laying their eggs. And this is the primary prey, the food source for our beetles are the eggs of the cystins generation. We rear two predator beetles, both in the genus Laricobius nigrinus, and Laricobius ossicensis. Through the years, we've reared three other predators, two on kind of a trial basis, and the other one was Sasagiscimus sugi, the ST beetle, that was relative to Laricobius, easier to rear, but we put there's hundreds of thousands of them out there, but it didn't work out in the field too well. Laricobius has proven to be a better predator than Sasagiscimus. Rearing predator beetles successfully depends entirely on bringing in healthy in a large amount of HWA, ovipositing HWA, those that are laying eggs, the females laying eggs, because as I mentioned, the eggs are the primary prey for the beetles and the immature stages especially. This is always probably one of the biggest problems in rearing is during the rearing season, you got to go out one day a week and go out and collect these adelgids from the forests. The process we go through in rearing the beetles, we take those the branches that we're bringing from the forest and process them. We cut off the twigs or the ends of the branches that are most heavily infested, and we'll make bouquets of them and place them into gallon plastic jars that are ventilated. And in each jar, we'll put, depending on how many beetles we have, 20 to 22 beetles. We can't sex them because you can't tell the sexes apart, at least for nigrinus. With ossicensis, you can. The males are darker than the females. So we put these in the jars and we give them a week, the females a week to lay eggs. And then every week we'll go through these jars. Each jar pull out the foliage, and this is done within what we call these bug dorms, these small tents that we keep in the lab. Find the beetles, put these beetles back into a fresh jar with fresh foliage and adelgids. Replace the ones that have died to bring that number up to 20 or 22 beetles per jar, and do that again week after week. This we have to use various temperatures to rear the beetles at. For oviposition, egg laying, beetle egg laying, we hold the jars at 50 degrees Fahrenheit. And that's these the rearing process was something that's worked out years ago at the Virginia Tech beetle rearing lab. Once we remove the foliage from the jars that have been exposed to beetles, the foliage from 4 to 5 jars are combined into one large bouquet. You see here on the right, and more foliage, fresh foliage that hasn't been exposed to beetles are provided for extra food. And these are placed in a special cage. You can see here, this is about 2 feet by 2 feet by 2 feet. And it's held at, for the immature development, the larval development, they're held at 55 degrees. In about 4 weeks, the larvae have start dropping. Here in the bottom left, you can see this is a mature larva feeding on the egg sac. Once the larvae have matured in the forest, they'll drop from the tree, burrow into the duff layer, that top layer of organic matter, and that's where they'll pupate. They form a cocoon, if you will. So what happens in the lab is when this is going on, this part of the rearing process, the larvae drop out through a screen bottom here and drop into a drawer. We pull open the drawer and take those little larvae out, usually one at a time with a small paintbrush, and put them into soil that we've, as you can see, that we mixed in the lab. And this has to be done, when this is happening, it has to be done every day. In fact, during the week, it'll be done twice a day. It has to be done even on weekends. The beetles don't take holidays or days off, weekends off. To me, it's like you have pets or children to take care of. Someone has to come in, someone has to be there 7 days a week when the larvae are dropping and the beetles are emerging in the lab. So up the top left, this is the Laricobius lab. We have several of these rearing boxes, and at the height of the season, all these boxes will be full of bouquets and larvae dropping out. Let's see, what do I want to mention here? So this is all going on right in here. What I want to mention is that, there's 2 generations Rusty mentioned. There's the cystins and the progrediens, and the progrediens don't lay near as many eggs as the cystins. So our main food source are the eggs that are being laid right now. Later on in late winter, spring, we still collect adelgids from the field. They're still laying eggs, but not as many. But to extend the rearing season, we'll use these progrediens eggs also. As you can see, we extend it all the way into June. And here's a collection of our soil boxes. Each one of these contains 200. We've placed 200 mature Laricobius larvae, and they'll burrow into the soil. Something we mix up in the lab with ingredients that we buy just at like a Home Depot. Been using organic peat moss. You mix that in well with this play sand, clean sand you can get from hardware stores. And you mix that at a certain volume, and then you mix in water at a certain ratio. This is by volume. And now I'm going to move into the specifics of this past rearing season. With Laricobius nigrinus, we used what's called the coastal strain. There's also a strain that's been used called the interior strain. Coastal strain originated from the Seattle area. My colony, it was last collected from the wild in Seattle in 2019. Of course, we were to maintain a colony from year to year. We'd have to go out in Seattle every year to start anew. The intermediate, the intermountain or interior strain is reared at Virginia Tech, but it's really tough collecting those beetles from the mountain areas of Idaho is where they usually collect them from. In Seattle, you can go out on a good day and collect 200 to 300 beetles. In the past few years, I've been supplementing the Nigrinus colony with beetles collected from Western North Carolina. Thank you, Margo, for helping out with that. Postokensis, what I have in my lab is called the Southern strain. This is a strain that I collected in December of 2015 in the Kansai region, which is the southern Honshu, the big island of Japan. That's around the Osaka, Kobe area. Most of the beetles were collected in, went to several sites when I did that, but the vast majority of the beetles were collected in the rural areas north of Kobe, west of Kyoto. Not many beetles were found in the urban areas of Osaka. And in 2019 or 2020, I supplemented this colony with the F1 beetles, that first generation beetles that originated from northern Japan. Seems like every year, at least every other year, Virginia Tech will send a crew to Japan and collect in the north of Japan. The thinking is that the southern strain would be more acclimated or would work better here in the southern U.S. and the northern strain in areas in Virginia and north of there. Particulars of the past rearing season. We set up the oviposition jars in late January 26th. And those jars were reset weekly until mid-June. We had over 8,200 mature larvae drop from this foliage that had been exposed to the beetles. And they were put on soil, collected, from the drawers beneath the bouquets here, collected and put on soil from February 9th to mid-July. And if you're doing some math, you're kind of looking at this and saying 126, takes 3 to 4 weeks. That's not 4 weeks. Probably some of the larvae will drop out early. They're not mature, but they were collected in the lab. I'll always put them back in the bouquet if they look smallish, but sometimes they accidentally get put into the soil jars too early. And we've had so far 5,638 adults emerge, beetles emerge in these soil containers. And speaking about these temperatures, I mentioned that we use 2 different temperatures for egg laying, a temperature for the larvae to develop at. Once they drop out and are in the soil, we hold them for maybe 4 to 6 to 7 weeks at 55 degrees, but to simulate the warming temperature that they would experience in the forest, we put them in another chamber at a warmer temperature and slowly raise that up to 63 degrees Fahrenheit, and that's our summertime temperature. The predators, the Laricobius is very in sync with its prey. If I can go back to this, yeah. This time of the year, the crawlers here, late spring and summer, they're settled, they're not feeding, they're not food for the beetles. And so Laricobius, being in sync with their prey, they are in the soil this time of year, estivating, which is like a warm weather type of hibernation. That's why they're such good predators for HWA. Down here. And now it's right here, I think. So we had 54% survival of adults emerging. In fact, you can see they're still emerging. Had some 1 or 2 emerge yesterday. And that's not too bad. 54, I've gotten as good as 82% with Nigrinus. Osakensis is not as well. I've gotten over 60%, but 54% for Laricobius in the lab is pretty good. We don't know, really have a good whole handle on what it is in the forest, but we do know it's a lot less than that. Their survival from mature larva to adult emergence. Going back to temperature, I know I was forgetting something. In the fall, we slowly drop the temperature from 63 down to 59, and that stimulates the beetles to emerge, because that time in the trees, when the temperature drops, the adelgids break estivation, they're starting to feed, and they're growing and putting on wool, and then they become prey for the beetles. But the beetles will not lay eggs until the adelgids are laying eggs. This is our the emergence of the beetles in the lab over time. The orange line is Osakensis, and Nigrinus is blue. And this happens year after year. Osakensis always, the emergence is later, even though we had some early emergers here. The real emergence didn't start until mid-October, and it's always later than, and peaks later than Nigrinus. And that's a good thing, because it's always a problem that we have early beetles emerging early, and there are no adelgids to present them, even the small nymphs that are growing, because those estivating nymphs are not a food source at all. They tend to survive better when you can provide them with growing adelgids. So this is another advantage that Osakensis has over Nigrinus. Another reason that it's favored is that in the lab, studies at Virginia Tech indicate that it's a better predator in terms of how many eggs it destroys and feeds upon to complete its development. Releases we've made in the past year. This is for Nigrinus. A new site, two new sites actually in Bledsoe State Forest, one for Nigrinus, one for Osakensis. Surprisingly, I've never been to Bledsoe before this year. It's down there near Fall Creek Falls. And as far as state forests go, it's more of a pine plantation. A lot of it's in pine. But there are a lot of forested areas and some decent hemlocks that are along creeks. And appears that in most of the areas I've seen that the adelgids is just getting started there, surprisingly, considering how long the adelgid's been in the area. See, I made 2 releases at one site for Nigrinus, releasing over 1,000 beetles. The more beetles you can release at a site, the better chance of them becoming established, but you don't want to, concentrate them all there. You got a lot of other sites you want to release at. In the past, now I like to, recent years, I'd like to release about 1,000 beetles per site. Sometimes this year I did a few sites where I put them out within a few weeks of each other, those 2 releases. In the past, I've done it where I put about 500 out one year and 500 out the next at the same site. Cumberland Gap, I've been working with them for several years, making releases up there. Most of those, almost all of those have been in the Kentucky part of Cumberland Gap. And one large release we made. Good thing there is they found, I think, 3 or 4 areas where Nigrinus is established and spreading. Worked for several years with the Kentucky Division of Forestry, providing them with beetles for making releases in the Daniel Boone National Forest. And the strike team mentioned this earlier. We made a couple of releases there. They went off on their own. For the first release, I gave them the jars with the beetles, and they put them out along one of the main hemlocks, one of the main roads there at Fall Creek Falls. And I came back less than a week later with the second batch of beetles that we released at the same site. Frozen Head, this was a supplemental release. The year before, I put out about 500 at this site. Some of you familiar with my injury I had in 2019. I cut my foot pretty bad, and I wanted to get rid of some beetles. Couldn't walk far. I knew of a site here at Frozen Head where I could drive right up to the trees. So I went there, released 500 beetles, 2019. Came back a year later and made a supplemental release. In the South Cherokee, I haven't released there in quite a few years. Rode down just to see what was happening on Citico Creek Road, which is the northern part of the Southern Cherokee, and found the area where I'm not sure if the trees were never treated or that's rebounding from prior treatments. It's hard to tell because a lot of the areas there that the Forest Service has treated, they do not mark the trees. So I made a couple releases of Emergence there, the last one being just a few weeks ago, actually, on the 14th of January. You kind of adding this up. This does not, you see the numbers that we produce. This is always a problem. You can't get all the beetles out before they die. You're storing them in containers until you have the time, or the delges are ready to be released upon, and they're always going to die. They're always dying off. And also there's a problem with how many do you want to hold back for rearing the next year? You don't want to lose your colony, so I'm always pretty conservative, holding back close to 1,000 if I can for rearing. So that's why the numbers you see here that have been released are not close to what we actually reared that emerged in the lab. Same goes for Osakensis. New releases from late September to just a few weeks ago. Again, Bledsoe State Forest, found another good site there for releasing. Made 2 releases. Once again on a creek. Fairly large trees. Most of what I could tell were pretty heavily infested, the branches. Once again, providing beetles again for the Kentucky Division of Forestry. Of course, we worked a lot with the Great Smoky Mountains National Park. Jesse Webster and his crew went out with them one day to the Elkmont area where Emergence had been released and had been established, but hasn't been seen in a few years. So Jesse Webster wanted to try an Osakensis release there. And that seems to be the trend. I think more people making releases really would like Osakensis, and I don't blame them. Of course, we can't get as many of them now because as you can Emergence, because if you saw in the numbers that in Rusty's talk, in some areas they're able to pull out, just thousands a year to move to other areas. Can't do that with Osakensis yet. At the present, there are 2 sites in Pickett State Forest where we made releases. This is a new release site, not far from the Kentucky border that I found. And then this is a release site that we put out in 2018. Jackie and her crew, I went out with them to make a release, and I made a supplemental release there. I provided 600 LOs to Margo's group for release in Western North Carolina. For the first time ever, I shipped some beetles up to Tom Macy in Ohio for release there. And just a few weeks ago, we shipped some beetles off to Greg Wiggins, a former UT employee who now is the biocontrol administrator for the NC Department of Agriculture, where they're doing a project for the Forest Service. They're going to release eggs, Osakensis real eggs, for releases rather than adults, to see how that pans out. Okay. Did something a little different this year. I went back to some of the release sites that were near where I was going to collect some food and brought in some infested foliage to see if there were Laricobius larvae already there. And in the earlier presentation, the strike team showed you hunting for the beetles. And that's a quick way to find the beetles and get them identified. But the better way to do it, and not everybody can do this because you really need a lab, is to go out, collect HWA infested foliage in the spring, ideally not before the middle of March and on into late April, because by then the eggs have been laid, the beetle eggs and the larvae are developing, you can bring that foliage back in the lab. If you can, put it in the bouquet and rear out those larvae and collect them and then send them off for identification. And that's what I did at 3 sites. The most surprising one and the best results were at the Pogue Creek Canyon State Natural Area, where I released Osakensis back in 2016, 2017, released about probably 1,100 beetles. And a shout out to the strike team. They helped me make this release in really miserable conditions back in 2016. So let's see. This is the foliage I brought back from Pogue Creek. Not a lot. This is a meter stick, so that's like 22 inches from end to end. But from that foliage, 150 larvae dropped out, Laricobius larvae. I shipped 30 of those up to the Virginia Tech lab. Only 30 because that's all they really want to deal with from one site. And lo and behold, they all turned out to be Osakensis. That was fantastic. Surprising too, because there are pines near this release site. And I was thinking I was going to get some of the native Laricobius rubidus, but it turned out to be all Osakensis. What do the trees look like? The release trees, kind of shabby. They're still alive. They had some new growth on them, not many adelgids. All this came off of trees that were like 6 feet or smaller, pretty small trees. And but they were all heavily infested like this. And the 2 other sites I collected from, one was Frozen Head State Park. This was at a site where I released way back in 2010. It's never been surveyed before or sampled before for see if the beetles have been established. Couldn't find many adelgid infested branches. Just a few twigs I could bring back from that. 5 larvae dropped out. All 5 were ID'd to be nigrinus. Fantastic. And back up in the northwest at Pickett State Forest, I went to a site that actually Jackie and I made a release way back in 2018. Made the initial release. I came back a year later and released about probably 500 more for 1,000. And early last year, I had some beetles. I'm talking about the beetles that will emerge early in the lab, and you don't want to hold them there. If you do, they're just going to die in a jar. So I'll take them out to prior release sites. Usually make these supplemental releases. So I think I released 40, 45 beetles maybe in September of 2020. So that's why I got the asterisk there, even though we found 3 nigrinus larvae there. Because I made that small release in 2020, this is not confirming that the beetles was established. These progeny could have been from the beetles that I released in 2020, but it's a good start. And one other, that's there. Activity I participated in was the silverflower release. Cooperating with Cornell, the grad student Nick Stiechler there. He sent me 500 Leucothoraxis pinniperta, and I released them in April in the Pickett State Forest. And this is the site of an earlier nigrinus release, not the same one I mentioned before. This is one that's on the same road, but not near that prior release site. So it's interesting to see how this will play out. So that, I think, is all I got to say. I got one more slide just to show you how many beetles we reared over the years. See how many mentioned now. ST is less difficult to rear. They just lay tons of eggs in the lab. Fortunately, it just didn't pan out in the field. Quit rearing them in 2019 and now focusing only on nigrinus and primarily on Osakensis. And that is the end.
Awesome, Pat. I'm actually really excited about what's going on at Pickett State Forest. Pat and I visited some really great release sites there. And so the fact that we have now nigrinus there, and silverfly. That's going to be really interesting. I'm interested to see what happens with that. And I'm also very surprised, and Lisa Huff, you should be excited about this, about the number of larvae that you collected at Pogue Creek Canyon. That's fantastic news. If you and the lab need any assistance with collecting infested branches near places that you've released beetles, the team is more than happy to go out and collect that for you and bring it back for you. So,
Okay.
does anybody have any questions for Pat? You've got congratulations on your retirement, Pat, from Sue and Brant Miller. And Brant continues on and thanks you for how much work you've done for the Hemlock project here.
Yeah. Thanks, Brant.
He also says great presentation and work.
Great.
Pat, so you mentioned, I have a couple questions. You mentioned that, and Rusty mentioned that when the beetles are released, that it has been shown that when people go out to survey and monitor that the beetles have moved from the release site. Do you have any information about how far the beetles move and how long it might take them as far as like months or years or such?
Well, I think Rusty mentioned that, at Virginia Tech, they've done a lot of work on that, and they've got, got some numbers. I think they've moved like 30 miles from release sites, but that's not totally forested areas. That's kind of like suburban, maybe urban forest type situations. In true forests, I don't know. I don't recall any data on that.
Lisa Huff, who is TDEC State Natural Areas, she manages Pogue Creek Canyon and a lot of the state natural areas in this area where I live. She says if you could ever really get a really good infield photo close-up of the larva collections, that would be really cool. Would love to learn what they look like.
It's pretty simple. Just go snip go to the right time of year. Tip, snips of the branches. You can bring them to the lab. You can actually do them yourself. But what you do is, I know Bud Mayfield worked out a real simple, cheap way to do it. Is you put them in. Of course, you got to buy that floral foam to keep the branches fresh for the larvae to finish, allow them to finish their development. Because sometimes it can take maybe 3 weeks from the time you collect the branches to where the larvae actually drop out. But he places them in a 5-gallon bucket. The larvae will drop out in the bottom of the bucket and they'll crawl around. You can see them fairly easily. And then you take a little paintbrush and you have to store them in alcohol. You put them right into alcohol, 95%. And that's what you ship off to Virginia Tech. And they get funding for doing that. I think the Forest Service funds them for doing that analysis, the mitochondrial, the DNA analysis. But it takes several months because there's so many people sending in. And that's the better way to do it. Looking for beetles is like needle in the haystack. There are a lot more larvae out there than there are beetles. So it's easier to find the larvae.
Yeah, it sounds like the HWA strike team would benefit from collecting infested branches where you have made releases before and then bringing them to you in the lab. Speaking of which, Pat, do you need the team to bring food for the beetles to the lab?
It would help, certainly. Anything you can bring it, like past, anything you can bring in.
Okay.
I'm looking at Brant here, and I didn't see on Rusty's map that Osakensis had been found in Catoosa, because I knew I found it there a few years ago. And me and Brian Chandler went out and made a release, and it took. So I may have to look in the database and see if that had been put in. But.
Yeah, I had the team. Katie, if you can remember, I sent the team locations that you had sent me, Pat, and told them to go out and beat for beetles in those locations. But if you want them to go collect tips of branches to possibly look for larvae, Katie can do that. Do you know where you guys surveyed, Katie?
All of the locations I think you gave us in Catoosa, but it was also super cold.
Oh, okay. Yeah.
Just super cold.
Yeah.
For looking for beetles, you want it to have it. It's got to be above 40. Ideally, is 40 to 50 to 55. Sunny, windless day. That's the best conditions.
So
For all
not
of us, right?
And it
February.
wasn't for yeah.
All right. Does anybody have any other questions for Pat? He is our beetle biocontrol expert here in the state. So he would be the one that you could ask your questions to. We do have another presenter coming up at 12:30 Eastern, 11:30 Central, but we can ask Pat a couple more questions. So I'll open it to anybody who has questions for Pat.
I don't know if they have my email or not. Is there a list that's put out to the
Yeah, Pat,
attendees?
yep, I just recently added your, I took your old email off and put your new email on for
Well,
that. And
actually, I got my old UT email back. They finally
Oh,
got
you
me
did?
back in the system, so you can use that one too. Either one works.
Okay. Do you have access to the chat there, Pat, or do you want me to type it in the chat box?
Let's see. Yeah, I do.
Okay.
Okay, I'm not sure how many have. Okay, I think I've seen all these. Congratulations. Right.
All right. Well, thank you, Pat, for that presentation. Like I said, I've been working with you since 2017, and it's been great the whole time. I've had a lot of fun. I know that Hannah Hollowell, our forest health specialist, she is the bug person more than I'm a bug person. She has a degree in entomology, but I've definitely loved it. And I try to show that passion for all things hemlock and hemlock bugs as much as I can.
Right.
And so I appreciate your guidance and mentorship through all of that. So thanks so much.
You're welcome. My pleasure. Thanks.
Yep. Okay, so next up, we've got Margo Walston, the director of the Hemlock Restoration Initiative. I met Margo in person back in 2019 at the Hemlock Woolly Adelgid managers meeting on the national level. Margo has been working, I don't know, Margo, how long have you been working for HRI?
I started in August of 2015.
Nice.
So whatever that math is.
Yeah. So Margo, if you want to go ahead and set up your slideshow, we'll give people about a 7-minute break, it looks like. So get up, stretch your legs, grab something to eat, use the facilities, and then at 12:30 Eastern, 11:30 Central, Margo will take the show.
Thanks, Jackie.